is it. So how would you solve for y here? If you let x be 0, you go back to where? Here? If x is 0, what's y?
0.
Okay, if x is 1, 1 cubed, 1, right? If x is negative 1, negative 1 cubed, negative 1. And you get those same three critical points, right? Okay, we have the critical points. Now we need to calculate d at each one of those critical points. We have 3 different d's to calculate. There might have been some other ways to get those points as well, some other algebra. All right, so let's calculate d at 0, 0, which means we need partial of f with respect to x twice at 0, 0, partial with respect to y twice at 0, 0, minus the partial with respect to x then y at 0, 0, and then that squared. Okay, let's plug 0, 0 into the partial with respect to x twice. What do we get? 0. Times partial with respect to y twice, 0 in there, okay. Minus partial with respect to x then y. It was negative 4, right? Negative 4 squared. 16, but it's being subtracted. 0 take away 16, negative 16. What does that mean? We have a saddle. We have a saddle at 0, 0, right? I'm going to go even further at 0, 0, 1. So I actually gave you the point on the surface. If I plug in 0, 0 into this, right, I get the actual point. That's the point 3-dimensional space where I should see a saddle point. Calculate the d on the others. Can you do that real quick while I get a drink? Are there questions on how I got this or no? What's your question? Like, where is that point on the surface? Well, we just go up to the surface, right? Plug in 0 for x and y, and we just get 1. That's where I got it from. Yep. All right, I'll be right back. I just need something to clear my throat and carbonated.
Do you get heartburn?
Will that give me heartburn? So take it easy, right? I just need something to clear my throat a little bit. All right, y'all get it? Y'all calculate it? D11? 128?
Yes.
Okay, I'm interested to see. So it was what, 12? And then times 1 squared? Wait, 12 and 12? 12 and 12, then minus negative 4 squared again? So 144 minus 16, 128. Okay. Any questions on how we got that? So what's our conclusion? So far, this tells us that D is greater than 0. When D is greater than 0, you don't know. It's either a local max or a local min. You now need to check the second partial with respect to x and see if it's positive or negative. That means which of these parts was the second partial with respect to x? This one. You're now going to defer to that number. And that number is positive, isn't it? That second partial is greater than 0, which means we are local min. Local min. So if this is positive and that's positive, you're a local min. If this is positive and that's negative, it's a local max. So we have a local min at 1, 1. And I'm going to also find the z coordinate. I'm going to plug 1 and 1 into the original. Negative 1. Okay. Remember, this right here, if you're wondering what that is, that's f of 1, 1. That's the original function with 1 and 1 plugged in. All right, now we need d of negative 1, negative 1. Is it 128 again? Yep. But what's the first number? It's negative 12, right? Or no? No, it's positive 12 still? Oh, it is, because it's squared. So it's the exact same result, isn't it? So 128, right? That's positive. So this d right here is positive, but then also this right here is positive as well. So we've got a local min again at negative 1, negative 1. Negative 1 again? Yeah, negative 1. All right, y'all ready to see it? We have a saddle point at the origin, right? We have a saddle point at the origin, then we got two local mins. See the saddle in the origin? That's our function. All right, next example. The thing that starts to get messy here is the algebra. Whoa, whoa, whoa. I had it. Okay. Is that all right? Can you all see that? Did y'all like that, making the list of things here? Remember, right now, we're trying to find local max and mins of a surface. There's no domain restrictions. So all we're doing is figuring out the critical points and calculating D. That's all we're doing. Okay, so partial with respect to x. 3x squared y plus 24x. Y'all agree? Okay. Let's go partial with respect to x again. 6xy plus 24. Partial with respect to y. X cubed minus 8. Partial with respect to y again. 0. Partial with respect to x, then y. 3x squared. All right, there it is. This is not the worst thing I've tasted. My wife put this energy drink in my, like a healthy energy drink in my bag the other day. I tasted in the middle of class, I almost like spit it out. I was like, that's what she gave me.
Which one?
I don't know what flavor it was, but it did not go well for me. I love V8, the regular V8,
Yeah.
especially the low sodium one. I love it, but I have to be in the right mood for it. Yeah, I don't know what flavor it was. Do you like those?
The good ones is black cherry and blueberry pomegranate.
Okay, I'm not
Is that
sure.
the orange one?
I think it was the orange one.
That's not the orange one.
Yeah, but I don't know. Could have just been my taste buds that day. All right, we ready? Got all the partials? Now, we've got to figure out first our critical points, right? Critical points, then we calculate D. I need to figure out where that partial with respect to x is equal to 0. So when is 3x squared y plus 24x equal to 0? I also must figure out when is the partial with respect to y equal to 0. And, ooh, that one's nice. Because I can solve this one. There's only one solution here, 2. The only number you can cube and get 8 is 2. And once I know that, I can go back and plug it in over there, right? So now I know this. I can come in here and say, oh, if x is 2, then 12y plus 48 equals 0. Solve for y. Y is, what is that, 4? Y is 4. Negative 4, thank you. Yeah, it is negative 4. Right? Y is negative 4. Okay, so there's only one point, right? One critical point, 2, negative 4. That's our only critical point. That's because there was only one solution here, right? There was only one solution, which meant I have to stick with that x. So now I'm going to calculate D. D at the point 2, negative 4 will be equal to the partial with respect to x twice at 2, negative 4 times the partial with respect to y twice at 2, negative 4 minus partial with respect to x then y, I'm going off camera, at 2, negative 4, that thing squared. Okay, what happens partial with respect to x twice if you plug in 2 for x and negative 4 for y? You get 6 times 2 times negative 4, and then plus 24. Yeah, so that's negative 24. Okay, and then the partial with respect to y twice, oh shit, 0. Okay, that's 0. 0, right? And then minus partial with respect to x then y at 2, negative 4. 3 times 2 squared. But then all of that squared. So you wind up getting 0 take away, who cares? That's a positive number, right? 4, 12, 144? 4 times 3 is 12 squared. All that matters is what? This is negative, right?
Yeah.
So D is negative. What does that tell me? Saddle. Saddle. All we have is a saddle point, and we have a saddle point at 2, negative 4, and then we'd have to plug it in, wouldn't we? I think I did it on the computer already. Let me bring up the surface. Really kind of a cool looking surface, if you ask me. I'm curious, do y'all want to see what this looks like in Desmos' new graphing? Or do y'all, no, don't care. Well, what I want to do is I want to see, can I use this one? What I want to see is how the zooming works. I wasn't too happy with it. Oh, shit. Sorry. So here's the surface, okay? Kind of cool. See that little ripple in there? It's kind of cool. Okay, so it's 2, negative 448. So the point is right there. Do y'all see the point? The black point right there? That's where our saddle point is on the surface. Let's see what Desmos does with this. Someone's going to have to read it out to me when it's time. Y'all ready? Okay, let's go to Desmos. I'll save this. Let me do new blank graph. Okay. Z equals x cubed, y plus 12 x squared Just y? Okay. There it is. Oh, shit. I already don't like it. I do like that it rotates like that, but so obviously I need to adjust the window, right? Zoom it or something. Not real happy with this. So in here in Desmos, I'd have to go in here and like change the bounds, physically like type new numbers in here. Let's try, what's the other one, GeoGebra? I'm not expecting Desmos to be great to start, you know, they just betaed it, but x squared y plus 12? X cubed y.
Plus 12x squared.
12x squared minus 8y? Wow. Okay. Well, maybe I shouldn't have said anything. I don't know. So obviously I wrote the code. Here's my code to make this graph in Wolfram Mathematica. So I adjusted the window the way I wanted it and stuff like that. But there it is. Okay. All right. Next one. Let's get all those partials. Partial with respect to x. Okay, derivative of e to anything is itself, right? So we have e to the 4y minus x squared minus y squared times, now we take derivative of what's up there with respect to x, which is negative 2x. That's it. So that's your partial with respect to x. Let's clean that up. That's negative 2x e to the junk. Let's just say junk because I don't feel like writing it over and over, okay? All right? All right, let's do the partial with respect to x again. Crap. Well, if I take derivative of this, it's going to be a product rule, isn't it? I have a product right here. So I'll apply the product rule. The derivative of this one is negative 2 times what? E to the junk, right? Plus, now you take derivative of e to the junk. What's derivative of e to the junk? Well, didn't we do that already? And isn't it that? Okay, so I'm going to write plus negative 2x e to the junk times what? Are y'all following what I'm doing?
Yes.
Yeah, everyone following? Okay, so that's the derivative of this, right? Now I still need what next to it? Times negative 2x. All right, let me try and clean that up a little bit. I have negative 2 e to the junk. Can I just do j because I don't even feel like writing junk anymore? Plus 4 x squared e to the junk. And by the way, junk, I got that from my professor, like my vector calculus. I took 4 calculus classes. When I was in college, they did a little different. Instead of doing, we do 3 4-hour credits, right? We have Cal 1, Cal 2, Cal 3. When I took it, I took 4 3-hour credits. So I took Cal 1, Cal 2, Cal 3, and then I took a Cal 4, which was vector calculus. So anyways, my vector calculus professor used junk all the time, and so I use it too. All right, do y'all agree we have that? Okay, see, so I can stop right here, but I'm just going to continue to clean this up. I'm going to factor a negative 2e to the junk out, and that leaves me what inside? 1 minus, I think you're right. Right? We pull the negative out? Minus 2x squared? Yay or nay? If I do this to here, I get negative 2e to the junk. And if I do here to here, I get 2 negatives become plus. Yeah, I think that's good. I didn't need to do that step. I'm just doing it. All right. There's my partial with respect to x twice. Okay, partial with respect to y. Please be better. It's e to the junk, right, times derivative of what's up there with respect to y. 4 minus 2y. Okay. I'll just leave it like that. Well, maybe I'll write it the other way around. Maybe I'll write it 4 minus 2y times e to the junk. And that way, next step, product rule, right? Okay, derivative of this product, again, so the derivative of the first one with respect to y would be negative 2, right? E to the junk. And then plus, what's derivative of e to the junk with respect to y? Well, that's everything we're looking at, right? So again, we repeat 4 minus 2y e to the junk, but then times what? 4 minus 2y again. And I could clean that up too, right? Do we want to? I won't this time. I'll just leave it. All right, partial with respect to x, then y. Here's a partial with respect to x. If I differentiate this with respect to y, then I can ignore this, right? This is a constant out front. So I'm just going to have negative 2x. That's my constant out front. What's the derivative of e to the junk with respect to y?
E to the junk.
E to the junk times 4 minus 2y. We did that earlier. So that should be your partial with respect to x, then y. Watch our only critical point is 0, 0. Wouldn't that be great? It's not going to be, though. All right, questions on the partials. Now let's find our critical points. I need the partial with respect to x to be 0. I need the partial with respect to y to be 0. Okay, partial with respect to x is negative 2x e to the junk equals 0. Partial with respect to y equals 0 is 4 minus 2y e to the junk equals 0. Those are my two. This will be easy to solve. And the reason it's easy to solve is because these are multiplied, right? So what I can do is I can say, all right, well, what makes negative 2x equal 0? And then what makes e to the junk equal 0, right? This just has one solution, x is 0. Will e to the junk ever be 0? No, e to the anything is never 0, right? So this never has a solution, so I don't need to worry about it. And same principle here. 4 minus 2y, that must be 0. And then over here, e to the junk must be 0. That's never going to happen. This is y is 2. We only have one critical number. Critical point, I should say. Critical point. The critical point is the point 0, 2. You see how that e to the junk didn't really factor in too much? All right. I need all that, so I'm just give you a second here. I'm ready to move on. I'm ready feeling like a monster up here. Stuff's working. The can is like textured. That's weird. Yeah. All right, here we go. I just erased that. Probably needed that, but I'm going to calculate d at 0, 2. And that means do I need to write the formula again? Or can I just do it? Just do fxx at 0, 2. 0 for x. Hey, wait a minute. This is it right here, right? No, I factored. Shit, hold on. I'm going to have to do it. What was fxx when I cleaned it up?
Negative 2 e to the junk.
Negative 2 e to the junk,
Parentheses, 1 minus 2x squared.
2x squared. Okay. What happens when I plug 0 into that for x? And I'm going to have to write it out. I don't think I have a choice. Negative 2. I'm taking this right here and I'm plugging in 0 for x and 2 for y. So negative 2 e to the, okay, what happens when I plug in 0 and 2 into the junk? 0 for x, 2 for y.
Negative 8.
You get negative 8, right? 4 times 2 is 8, minus 0, minus 4. So e to the 4, right? E to the 4? We all agree? E to the 4th? So negative 2 e to the 4th. And then, what? 1 minus, this is 0. So that's it. Negative 2 e to the 4th. That's what I get there. I go too fast there, or are we all right? We're all right, everyone? Yes? Okay, that's just fxx, right? Now we need fyy. Shit. Same thing. So this will be negative 2 e to the 4th, right? Plus, what's that? 0? So negative 2 e to the 4th again. Minus fxy. Oh, 0, right? Should be 0 because that's 0. Everything else is going to go away. So 0. All right. That's going to be a positive number, isn't it? This is e to the 4th is positive times a negative. That's negative. That's negative. Two negatives become positive. So this is greater than 0. So d is greater than 0, which means I either have a max or a min. I now need to look at the fxx part. And the fxx part is this part. And that's negative, right? It's less than 0. So negative means you'll have a local max. Think of it back like when we were talking about, this fxx is a second derivative. Remember concave down, concave up? Concave down, concave up? This is saying our second derivative is negative, is concave down. That should be a max, right? If it was positive, it would be min. But you also need capital D to be positive for you to be thinking that way. So we have a local max at 0, 2, and then if you plug 0, 2 into that, I think we got e to the 4th, right? There it is. That's our conclusion. Shall we take a look at it? I'm not going to go to Desmos or anything, but I have the graph ready to go. If I'm not mistaken, the graph of this, I call it the pimple function, because it looks like a pimple. If I didn't mention that, it probably wouldn't be as sick. But yeah, there it is. Just a little pimple. There it is. Just a little pimple. There it is. That's the surface, and we just found 0, 2 e to the 4th. That point right there. Yes?
So given basically the restrictions of what we can do, fxx will never be equal to 0? It can't be, right?
Well, it could be.
Greater than, less than, I mean, it's...
Yes, so you're bringing up a good question. What if capital D is 0? It's actually inconclusive. The test fails to work, all right? Which I'm going to give you a problem to take home as a bonus to see if you can figure it out.
Okay.
Yeah, where that's going to happen. You can still figure it out, but the question is how, right? So I've got a little bonus question for you, but let's do this one. Y'all getting the basic idea here? It's just a lot of computational stuff, right? I recommend that we look at it this way. x squared plus y squared plus x to the negative 2, y to the negative 2. Look at it that way to start out. I think it'll be easier for us to differentiate that way. Right? That's the same thing? Okay, so let's do partial of f with respect to x. All right, 2x, 0, negative 2x to the negative 3, y to the negative 2, right? Because that's a constant on that derivative when I'm treating x like the variable. And then f with respect to x twice would be just 2 plus 6x to the negative 4, y to the negative 2. See how we don't have to deal with quotient rule or anything like that this way? Okay, fy. You'll hear how I'm saying fy, fyy. That's not the right language, but it's the easiest thing to say, right? fxx, fx, you understand I mean partial of f with respect to x. Partial of f with respect to y would be 2y. Very similar to what we had just a second ago. Minus x to the negative 2, y to the negative 3. I picked up a squeaky one here. Did I forget something? I did. Yeah, I did. 2y minus 2, right? 2y minus 2x to the negative 2. So I'm kind of not excited, but tomorrow I'm teaching my college algebra class, and we were studying parabolas. And one of the things that I was talking about is like, where do parabolas appear in the real world? And we were talking about in the beginning how we were trying to like lob, you know, when you're trying to fire something through the air, it's parabolic. We were talking about like, you know, when people were trying to storm castles, you know, they were just lobbing things into the castle. And then as we became better with math, we could actually predict and put our things, you know, put your shot where you wanted it. We were talking about like how warfare motivates technology, you know, the fact that humans don't get along really pushes technology, right? And they were just like, sir, that's very morbid, you know, and all this stuff. And I was like, yes, but, you know, just humans, we just can't seem to like get along with one another. And that's really what, and they're like, no, it's not. So, you know, what happened over the weekend, right? People can't get along, right? You know, it's just, so I'm gonna be like, oh yeah, I'm pretty morbid, right? Yeah, so is the world. So anyway, what am I talking about? Let's get back to this. Y'all are taking derivatives. I'm just yapping up here. What is this? 2 plus, it's very similar, right? Y to, wait, what the hell am I doing? What am I doing? Negative 4, but did we do that on the previous? Oh, yeah, there it is. Okay. Sorry. Whoa, lost track. Lost my mind there. That monster is getting me messed up. Partial of f with respect to x followed by y is gone. And then just